Thank you very much. I'd like to talk to you about something today that I've been interested in for about the last year. And I'll explain to you firstly what my role is at Sony Computer Entertainment so that you know a little bit more about how this is of interest to me and how I see it every day. I work within the third-party relations group at Sony. I cover independent developers in Europe and Australasia. There's about 450 different independent developers across that whole area. And there are 3 people in the team that I work in, and we look after all of those developers on a day-to-day basis. They're making games on any PlayStation platform, so they're making PSP games, PlayStation 3 games, PS2 games, and some of them still make PS1 games as well. One of the big changes that obviously we've seen, and I've been working on since about May last year, since about May 2005, is PlayStation 3. And I've been working with our developer community to bring some of the new PlayStation 3 titles to market that you're going to see in November and December this year. So I've been working on those titles with our developers for about the last year altogether. One of the things that was quite scary for developers when we first started talking about next generation 1 year ago, and before that even, was the size of the team that will be needed to make a next generation game. There was a lot of information in the press about you're going to need 100 people, you're going to need 150 people, you're going to need 80 artists, you're going to need 100 artists to make a next generation game on PlayStation 3. And maybe for some games, you know, this will be true. Maybe for the really big, scripted, very detailed games, this will be true. But what I want to talk to you today about is a new procedure, a new way of making games, a new way of generating art content that's become more and more popular over the last 12 months. And really now we're starting to see some very exciting developments in this area. And actually I think that over the next 1 to 2 years, the next 12 to 24 months, you're going to see some games, and we'll talk about some of them today, using some of these new techniques so that that team of 150 can actually be shrunk down to a team of 40 or 50 and maybe even smaller. Because actually, you know, most of that team was originally designed to create content. And as I say, what I'm going to discuss today is the way in which content can be created in new and different ways. So I guess what I'd like to prove to you by the end of today is that programmer art is actually really cool. Often when you're making games, I used to make games for about 12 years. Programmers tend to put some temporary art into games when the artists are too busy, and you'll see a piece here that was left in a game that actually went out on PC and was sold, say From Testicular with Love. So it's a little bit of a dangerous thing that sometimes gets left behind. But actually what I want to say today is that programmer art is actually very, very cool, and programmer art is actually the new way forward for some of these next generation titles. So this is what I'm going to cover today, the roadmap of what I'm going to talk about, starting with a little bit of history about the way content has actually changed over the last 20 years of gaming. So these are the old days, these are the good old days when everything first started, and I'm sure you're all familiar with this, you know, this way of drawing that was made popular by games like Mario, the guy on the right. And actually, you know, when you first started off, it was single color, it was binary information. So everything was drawn by hand. It's very nice to look at, it's very pretty, and when it animates, it's fantastic. But it's all two-dimensional, it's all dot by dot, it's all very, very meticulous. I'm sure probably some of you used to draw out characters and things on graph paper so you could get it right before you put it into the computer. So this is the way things used to be done. Eventually, though, 3D modeling started to creep in. There was gradually a transition to 3D, and that started first in wireframe with titles like Elite, and then moved on to for textured models as well. And these were the first times that we actually saw the generation of some procedural content. In other words, some of the art was generated by code, by procedure, by synthesis, rather than being drawn by an artist by hand. But in those days, you know, the example here is Sentinel, where the landscape was entirely generated by code. It was done through necessity. The limits of the platform were very, very tight. you had 32K to work in, sometimes 48, 64. There really wasn't much space to generate a huge amount of content, but people wanted to make big games. So Sentinel actually had 10,000 levels, but these were procedurally created levels. There weren't things that were drawn by an artist. But we see the start of, procedural content here. I'm actually going to do a little bit of a pop quiz now. So there's a telephone number up on screen. I'd like you to try and guess how many million galaxies there were in Elite. Okay, and if you have a guess, I've got two bags of PlayStation Portable PSP goodies down here that I'm going to give away at the end for the two closest answers. So try and guess how many million galaxies were created in Elite way back then, way back in the days of the BBC Micro. Text them to that number, and I'll pick out the two winners, the two closest numbers at the end of the presentation. So what happened next? Well, next we got the GPU race. This is really a struggle for triangle throughput. And then once we'd got as many triangles on screen as we could, drawing as fast as we could, they started to add effects per triangle and then effects per pixel. So where techniques like normal mapping allow for greater detail for far less horsepower, so you can actually get even more out of the GPU now, what we're beginning to find is that the percentage increase in graphical improvements per generation, moving from PS1 to PS2 to PS3, are getting closer together. As well as that, we always have PC in the background, and PC always tends to be slightly, that much further ahead, and then the consoles catch up, and then PC, and then the consoles catch up. So big horizons like 3D, where the perspective completely changed, where normal mapping was introduced and shaders, have all been reached. And there are a few holy grails like real-time radiosity, which is actually now being worked on by a company that have just announced their results, and that's very exciting. But these are being worked on in real time. But they require a general rethinking approach. And by and large, a lot of the huge graphical hurdles, which is aiming towards photorealism, have now been achieved in games. So people are starting to kind of look elsewhere. Alongside this has been the CPU race. So up until now, I'm sure you're all familiar with Moore's Law. Moore's Law basically states that the power of a system doubles roughly every 24 months. And you can see from this graph, up until about 2004, that was true, but not anymore. In actual fact, it's increasing beyond that. It's tending towards the 18-month line. Well, why has this come about? What it's come about is because basically semiconductor technology is now being limited by physical space. The chips are getting so small, the number of transistors so large, that actually there can't be any improvements made really now without going to a different solution. And cramming everything onto one single chip is no longer the way to go. On the other hand, the GPUs are extremely capable. As I say, we've achieved all those major results, and techniques like normal mapping have reduced the drain on the GPU. So some of the burden of the tasks being performed by the CPU has now even begun to be looked at by the GPU programmers. I'm sure you're probably familiar with GPU. Some of the work that Havoc have done in this area are actually moving some of its physics onto the GPU as well to take advantage of that. So the current solution to the limits of CPU power has been for cores to become multiple. Instead of having one chip, a single core, we're now moving to multiple cores. And the focus has actually been moved away from feeding the GPU with tons of triangles and tons of effects to processing those triangles and performing operations and supplying the content and processing that content before it's supplied to the GPU and afterwards and once it's rendered to screen. So we get to a situation where current day we also have the addition of multiple threads within a single core. When you're looking at new consoles, next generation consoles, the CPU side has tended to become either parallel, where the cores work alongside each other, or in the case of a platform like PlayStation 3, where they're actually asymmetric. You have your PPU and your SPUs supplementing that power as well. Obviously, parallel is probably a better understood approach at the moment. It comes from the PC background. but that's currently limited to being linear. Things need to be progressed and processed in a linear line. The asymmetric approach, which is being obviously used in PlayStation 3, is far more powerful. You get much better results, but it's harder in the first instance to schedule this and predict, and it requires a rethinking of some elements of architecture that have been linear before to work out how they can work in parallel. So the future on PlayStation 3 is that the cell architecture itself is uniquely positioned to define next-gen computational potential. The SPUs, the synergistic processing units, of which there are 7 in PlayStation 3, connected with a two-way ring bus, extremely high data throughput, are very vector math intensive. So you have vast processing power for calculation intensive processes. That doesn't just apply to things like physics, which are the obvious examples. It's also applying to animation, to image and audio processing, to AI. And the CPU in consoles like the PlayStation 3, for the first time, has enough power to generate content in real time through what's called procedural synthesis. Rather than relying on the old school methods of animators hand keying all the animation, artists drawing all the textures by hand, everything being created very slowly and individually, there's enough power on the CPU to do this in real time. So where we get to is a stage where the GPU has reached a certain level, it's extremely powerful, we're approaching kind of very realistic graphics. There are many different tools in the artist's vocabulary now. They can use specular bloom, they can use HDR, they've got normal mapping, we're moving towards real-time radiosity. All of these things are achievable by the GPU in real time. So they're now starting to look to the CPU, and programmers and game teams are looking to the CPU to generate some of the content and to do more things with the content before it's fed to the GPU. So where did this breakthrough come? Where did this point after, what we've talked about, first of all, Sentinel and those early games, where did the breakthrough for procedural content first come? Well, obviously the breakthrough came for effect. It's important to use procedural content to give better effects. Those early games were using procedural content because they had to, because they were limited by the platform. But the first time we really started to use procedural content used to get better results, to get prettier graphics, to get better simulation, was in the water in Baldur's Gate and Unreal. So these guys working on these games realized that actually there was no way that an artist could create really good water, through a basic, animation or through a set of textures. And games like Quake obviously had that approach, and they had 2 layers working together and various different approaches there. But really the best way to do water was to simulate it. It's obvious, but the power hadn't been dedicated to that before, and in Baldur's Gate and Unreal they tried it for the first time. Fluid simulation, fluid's a very, very complex thing. Fluid simulation used to be seen as a holy grail, the huge thing that you were supposed to aim for in real time. And gradually, the improvements in this particular area, just taking water as an example, have got better and better and better. We've seen other industries, like the film industry, where Scanline is a very well-known company, do great, fantastic water in an offline environment in films like Poseidon and Perfect Storm. But what we're now seeing is those results translated into real time on PlayStation 3. And actually, we have some example code in our SDK for PlayStation 3 at the moment, which does a full water simulation, all running on the SPUs, extremely realistic. Obviously, we have also IGEA and other middleware partners also pushing this area of fluid dynamics. So this is really, water is something that's not necessary to your game, but it's cosmetic. It gives better results. It makes the game look better. It makes the player more immersed in the environment. He walks through water and it drags around him, and it creates vortices. It creates true effects. And this is the kind of thing that now people are starting to look at with the extra CPU power. Something that you guys are probably also familiar with is one of the first games that was fully procedurally created, actually at the Breakpoint 2004 demo competition, and this won first place in the 96K category. But this entire game packs down into 96K and decompresses at runtime The textures, the animation, the enemy behaviors, all the patterns are encoded and procedurally created at runtime. So that was a fantastic achievement and showed what was really possible with procedural content generation. Where do we go from here then? Where's next? So we've seen those early games. We've seen the first kind of toes in the water, people playing around with things like water to try and get better effects. But clearly there's more to just, gaming than just water. There's other things that can be done with procedural synthesis. These are some of the key areas that are currently under investigation for next generation games, and I think these are some of the key places you're going to see changes in the next 12 and 24 months. So let's take animation to begin with. There's a guy who's been working in the area of animation, particularly facial animation, but also full body animation for many, many years now. He works at New York University, very famous, you probably know him, Ken Perlin. I attended one of Ken's talks 2 weeks ago, and one of the first things he said in this talk was that canned animation is dead. That's quite a big statement to make, but he didn't quite mean it like that. What he meant was that canned animation, where the animators are creating the animations and only the animators create the animations, is something that's past. What we're actually now going to be moving to is a situation where animators continue to use traditional methods like hand-keyed animation and motion capture, but these are combined with procedural elements to change the animation at runtime, or to reinterpret the animation and move it to a new context. So Ken Perlin is very famous for developing the concept of noise. And now he's actually moved the whole concept of a noise machine to being something of a procedural filter. So the example he gave was he took a walk cycle from Half-Life 2, and the walk cycle had been drawn by hand by an animator in a studio. And using his techniques and his code analysis, he actually analyzed this walk cycle and translated it into a procedural set of numbers. It was code, it was variables. And then in real time, what he did was he manipulated that animation so that the walk cycle had a longer stride, and the guy crouched down more. Now, no artist has done that. There's no artist gone back to that original animation and changed the various parameters and tweaked it and sat there for half a day making a new animation. He did all of this in real time, on the fly from the original source animation. So you immediately see that this is blending the traditional skill sets we have in the games industry, traditional animators who are excellent at what they do, and new skill sets, the power of this procedural emphasis to increase the potential of changing games very quickly, creating new content on the fly. The best example I think we've probably seen to date of humans, facial animation, is actually in Half-Life 2. And Ken Perlin's work, which I'll show you in a minute, was a key part. He worked with the guys at Valve to develop this for their facial animation. I'm sure if you've seen it, you will know what I'm talking about, but we'll show you in a minute anyway. And then I'll talk a little bit about the best example of creatures today, Spore. This is Will Wright's latest title coming from EA. I'm sure you've probably seen this as well. But this entire game uses procedural animation to actually create the moves and the characteristics of the creature. So this is Ken Perlin's basic tool for creating facial animation. If you go to his website, this tool is a Java applet. You can play around with it. But as you see, there's a very small set of different tweaks and different variables you can make. And the results you can actually get by just changing these and combining them in different ways, these procedural rules. There's a huge array of animations you can get, and these are just 5 that I did really quickly. And there are many, many more. But the other thing you can see is how effective these animations are at conveying emotion. You can immediately look at those and you can see, exactly what's kind of going on. Whether it's, the one in the middle, she's looking, kind of surprised and a bit happy, or the one at the far right looking very surprised. So it's very easy from a very simple set of rules, procedural rules, to generate many expressions. So as I mentioned, this work was actually used by Ken, and he worked with the Valve team to develop this for Half-Life 2. This here is taken directly from his Java applet using the basic rules, and this is a facial animation taken directly from Half-Life 2. And you can see, the similarities here, but I'm just going to play a little video now to show you the actual results of Ken's work within Half-Life 2.
rather busy in your absence, Mr. Freeman. Pay attention, Mr. Freeman. I'm only going to say this once.
那么，看来我们是没有合作的机会了。
So that's an example, probably one of the best examples to date of what is possible with just a very simple set of procedural rules to create this different content. And these are some of the expressions that the main character, Alex, has taken from Half-Life 2. And again, you can see the quality there is extremely, extremely high. The second aspect of animation, which is currently being integrated with procedural approaches, is full body animation. So full body is traditionally something that's either been done by, as we mentioned, traditional animators using hand key approach or motion capture. In actual fact, for about 2 or 3 years, a little while ago, motion capture kind of went out of favor. It wasn't very trendy, it wasn't very cool. And that was largely down to things like the cost and the speed of capture, the quality of data that was coming out. Since then, however, the whole system has improved, the cost has come down, the data coming out is much cleaner now. And the beauty of motion capture is that it really increases the lifelike motion of the characters. So motion capture is now becoming more and more popular for next generation games. As people want to make more lifelike animations, motion capture's coming back in. But you still need hand-keyed animation for animations which are too dangerous or too costly, for the actors to actually do, where the rig you'd need to set up is very, very complicated. But what we're seeing now is that there are a couple of tools in development, talk about those in a minute, which are actually using procedural animation to effectively take control of the skeleton. They simulate all the physical properties of the skeleton and the muscles as well. So it's not just ragdoll, it's not just skeleton, it's muscle architecture as well. And using these muscle and bone rules to actually control how the character behaves. So again, it's taking the idea of Ken Perlin, that you've got traditional flat data sets from hand-keyed animation and motion capture, and these are combining at runtime with procedural animation. This is a far more flexible approach than the offline one, because what happens is, in the game, there are many things that happen in a game that you just possibly couldn't predict, and an artist could never draw. You might have a character animation for when a guy walks into a wall and he bounces back like that, but that's a full body animation. You don't want to do an animation for when only his shoulder hits the corner of something and his shoulder goes back, or when his hand hits something and only his hand comes back. The number of animations would be absolutely huge. But what procedural animation allows you to do is actually do that kind of thing in runtime, have the control of the arm taken away and run by procedural animation solutions, and blend those then with the hand-keyed and the mocap data. So Havoc have obviously been doing experimentation in this area with behavior, their new product behavior. And Natural Motion recently won a developer award for Tools Provider of the Year. And I'll show you some of their stuff in just a second. But Natural Motion uses an approach called dynamic motion synthesis. This effectively adds artificial intelligence to the muscles, and they fully simulate a human body in terms of all its physiological makeup. They then combine this together with motion capture and hand-keyed animation to get the best results. And in fact, this technology will be used in the new up-and-coming Indiana Jones game. So this is coming from LucasArts PlayStation 3 in the near short term. So you might want to go and check that out. But what I'll do is I'll show you here a little video of Natural Motion's technology. And what you'll see is American football players running together. And when they run together, they're using the motion capture data. But at the moment they run together and tackle each other, all of that is under procedural control. There's nothing pre-computed there. It's all being generated on the fly in real time. And each time they collide, there's a different result. There's a unique result, because all of this is under the control of those rule sets. So what you can see, as I said, is each time there's a different result. The guy runs up, gets up, runs away. 3 guys coming in, and there you can see it in full data. So this is, there you go. It's all procedurally generated, and then blends back into the motion capture data of him running away. And you can have as many guys coming in, as many different angles as you like. So what does this mean for games? Well, what it means for games is that every time you play the game, it's going to be different. You can do the same tackle 1,000 times and you're never going to see the same thing again. It also means that animators who couldn't possibly draw all those different combinations, they could never think of all of those, and even if they can, they could never store them somewhere and retrieve them at runtime, are able to make truly lifelike simulations. The last example then that I'm going to just quickly touch on is Spore. Spore is a very extreme example of procedural content generation. Everything in that game, the buildings, the creatures, everything, the landscapes, the planets, is all procedurally generated. There's nothing in there that's been done by an artist. And I think Will Wright even said, you know, he took some of the guys, quite a few very talented guys from the demo scene, and he locked them away in a room for 2 years while they came up with this technology. So he's very well aware of like where this stuff comes from, and the guys like yourself who've been working on this for a number of years. So this you know, really expands the way you can control the game and how flexible the game is. I'll just show a little bit of a video here which demonstrates, first of all, the creature editor, and then shows you a few of those creatures actually moving around in an environment. And what you'll notice is how flexible this really is, how changes can be made very, very quickly and very easily using these simple rule sets. So this is almost like Ken Perlin's editor here. It's a very basic set of things, but you know, you want the feet a little bit longer. There you go. There's a new set of feet. Nobody's had to redraw that. It's all done in real time. Changing colors, I mean, this is fairly easy, but that creature's been entirely sculpted by the guy using this program. It's entirely unique. You'll never see the same 2 creatures again. There's a procedurally generated world here. Again, nothing drawn, all created, all simulated. And in a minute, we'll zoom into the world a little bit closer, and you'll be able to see some of the creatures that have been created moving around. So down comes the UFO. And here we're moving through the landscape, and there they are, some of them there. So the way these guys move, the way they kind of, you know, get around the landscape, the way they're gesturing there, everything's a basic set of rules. So what you can see is that this is the first steps towards kind of having high quality procedural content. The animations here aren't quite yet at the quality, you know, that we've seen before through hand-keyed animation, but they're certainly getting there, and certainly the, you know, this is the right approach to be taking. So what else can we do with procedural content, and what else are people doing? Well, the next major area is materials and behaviors. So we've already talked about water and how this can be procedurally generated and controlled at the moment. The next holy grail is fire. Fire has never been done that well in games, and fire tends to be largely something that's done by animators. It's flat textures, it's sprites with a few particles, and they're put over each other in layers. And you can get some great effects that way, but it's not really simulating what fire actually does and the way it spreads and grows and the way it moves around objects. So to get that kind of effect, you're going to need a lot of processing power. You're going to need to simulate the way a fire actually behaves and eats oxygen, and the way it heats up, you know, more in the center, and the way it flows, almost like water around the outside. And this is a true combination of cause and effect. It's a true physical simulation. But this is the kind of thing that people are now starting to talk about. We mentioned before Scanline, a company who does this offline. And if you go and look at Scanline's website, you'll find that they do fire simulation in an offline environment, which is fantastic. But what we want to see and what we're now starting to see is this done in real time. What you do also get is you get hydro and thermodynamic behaviors, the way fire, fluids, even things like gases expand and contract under pressure and under heat, and the various results that come from that. And you can integrate these within your games. So from GDC last year, quite a long time ago now, we actually had a demo that was shown by Phil Harrison, which showed in real time this garage exploding, debris flying out, and a huge fireball coming from this. Now, this was all generated procedurally on the SPUs at runtime on the PlayStation 3. There was nothing that was pre-calculated about this, and every time the simulation was run, there was a slightly different result. The physics was slightly different. The fire combusted in a slightly different way. Everything in here was simulated. The way the gases exploded, the way the heat actually propagated, the colors, everything, was all simulated, and as I said, all done in real time. What else? Environments. Environments are a huge part of games. Landscape, plants, roads. There's so much that goes into generating this content. There's so much time spent on generating these things. Many, many artist hours are spent creating these things. Well, the generation of plants in particular, in a procedural way, began with simple L systems and plant modeling. For example, you're probably familiar with techniques like the speed tree tools approach. And what naturally happened is that companies who were involved in creating plants through a procedural approach like Bionatics combined this with landscape rendering. And last year they bought a company called Blueberry, which provides them with a landscape renderer as well as plant rendering capabilities. This has already been seen, the creation of content, trees, fauna, landscapes in titles like Just Cause 2 on PS2, Just Cause on PS2, and also earlier on in Far Cry, where simply, the amount of vegetation there couldn't be done by artists. Terrain and landscape is naturally, the first step in actually creating this content, but there's far more to landscapes than just terrain and landscape. Roads can even be added as splines and then manipulated and controlled in a procedural way to take that away from the artist as well. One of the key elements, and I think one of the elements we're going to see actually next year becoming more and more popular in the next generation games is weather. Weather itself is a pretty huge system. We've started doing some work on this in things like the clouds in Warhawk. Now these clouds, which you'll see in the screenshot, are all generated in real time by the SPUs. They're not drawn by an artist, and the power of the SPUs allows those clouds to be ray traced. So the light completely realistically behaves both inside and outside, reflecting from these clouds. In actual fact, the water here is procedurally generated as well. But weather's more than that. Weather's more than just clouds, and a bit of water and some other behaviors. Clouds, cyclones, it's tornadoes, it's pressure, it's humidity systems and wind systems. And when you link all these things together, you get a true model of how weather behaves, and things like thunder and lightning leading to storms will naturally occur. They'll emerge out of this system. Now, there are a couple of developers that I'm working with at the moment that are actually working very, very closely on exactly this thing, is getting a realistic weather model up and running in their games so that things don't have to be faked anymore. The last thing then is obviously cities. I mean, cities you may think are kind of, how could you possibly procedurally generate a city? It's so unique, there are so many different signs and aspects and roads, but actually you can, and there's a lot of academic research already been done in this area. So this is taken from a paper that you can easily find on the internet. And the picture on the left demonstrates how a city, the overall pattern can be grown. And as you'll see, it's pretty realistic looking. It looks like it could be, somewhere like New York or Manhattan or London or even Helsinki. What you see on the right at the top is the buildings themselves, and those buildings are taken from slabs of polygons, and they're created, again, procedurally, and then combined with a grid system, the rules for the road system just below that. and the buildings are mapped onto that, so that what you end up with at the end of the day is the result of something like at the bottom, where you have about 1,000 buildings there simulated, and that's all being drawn in 3D in real time. As I say, there's a paper you can find on the internet. If anyone's interested, I can give you the details of that. But this is the kind of thing that is already possible. This is being done in academia at the moment at universities, but this is the kind of thing that we're going to see in games very, very, very soon. And what's the final big element to all of this? Well, all of this is completely useless unless you've got textures. Now, textures and texturing models probably takes up more artist time than any other single kind of aspect, other than maybe the exception of animation in the game's development process. Creating a texture through a procedural method is something you may think is almost impossible to achieve. How could you possibly recreate the texture of that chair and the texture of the iron bars there and the texture of the wood and do all that and describe it in a rule set? Well, in actual fact, you can, and there are a couple of companies working on this at the moment. This is really the last great hurdle to procedural content generation. Once we can do this, things will fundamentally change. At the moment, I said it's a massive drain on company resources to keep drawing these textures for each game. The granularity in the organic texture, nature of textures is very difficult to recreate. And obviously, people must always be kind of conscious of the fact that they've got to maintain the artistic quality as well as just creating things. So you could create a wood texture, but maybe artistically it wouldn't look that great for your game. You'd want a certain type of wood texture. So there's got to be some artistic control with it as well. One of the other major problems that a lot of game developers face is that they work with different publishers for different projects. Most don't have the opportunity to continue to work with the same publisher over and over again. So what actually happens is every time they make a new game, the publisher tends to insist that they create the textures for that new game uniquely every time. Even if they're doing another driving game, or even if they're doing another sports game, in exactly the same way, they've got to recreate those textures again from scratch. It takes a long time. And the last benefit procedural textures is going to have is on online gaming. So online gaming, every time you talk about World of Warcraft and then releasing a new world, that's a huge amount of content that needs to be put down a broadband pipe into your PC, and that takes a long time to get there, which means that they have to spend a long time developing these. They're probably going to have to sell them for a higher price, these new worlds. And, you know, the players won't be able to react and have the world change around them maybe as quickly as they would like. Massively multiplayer games tend to move quite quickly, and people would like to see new things. So that's limited by just the textures and the texture space that's needed. So the benefits of having runtime procedural generated textures is that once it's there, it becomes resolution independent. It can be in the background, it can be in the foreground. You don't need to redraw it for a high detail model and a low detail model. Everything is described in a set of numbers that scale according to how close it is to the screen. Also, as we said, there's a small packet size which is ideal for networks, but that means it can be transferred across mobile devices. So you can have the same texture representation, the same texture description on PlayStation 3, and the same on PSP. The same basic set of numbers is there, but it just scales according to the capability of the platform. And probably one of the most exciting elements of procedural textures and procedural content generation as a whole is that once you reduce something to a set of numbers, once you interpret animation as numbers, once you turn textures into numbers, once you turn everything, you know, the plants into numbers, numbers can be changed very easily. You don't need to go back to an artist to have them spend 2 or 3 days doing this. You can change it in real time, you can tweak the seed value, you can tweak any number of parameters, and it changes the whole scope of the game, the whole way everything looks. And that's quite an exciting change for games. It's something that's quite revolutionary, and I'll talk a little bit more about that in a minute. But what I want to show you first is a movie that's kindly been supplied to me by a company called Logarithmic. Logarithmic have a procedural texture solution at the moment. And what this movie shows is changing textures in real time to change the way an environment looks. I want you to pay close attention, if you can, to the crates in particular and the floor in this demo. And what you'll see is that as the demo progresses, these textures become more and more dirty, more and more distressed. and then actually they'll flick back to the clean version so you can see the difference. But this is all happening in real time. So if you're looking at the floor here, it's gradually becoming more and more dirty. It's getting worse and worse. And this is pretty much kind of as dirty as it's going to get. And then it flicks back to the clean state so you can see the difference there. But all this is being done with procedural textures. It's all being done in real time. So you can imagine, you come into the warehouse, it's very clean, like this to start with, the crate's very clean, and then gradually it becomes more and more aged, more and more dirty, more and more distressed looking. So what does this mean for games? I mean, the obvious example is a game like Silent Hill, a horror game, let's say. So you come in and you're in this warehouse and suddenly an enemy appears. And this enemy has the capability in a local environment, just around where he's standing, to warp everything, to make it very distressed, to really change the nature of what he comes into touch with. And that's something you often see in horror games where some enemy touches something and it becomes horribly distressed or aged. You can do that now. And in fact, as I say, you could do it in a local area. You could just change the textures just around where that enemy's standing and give this very horribly aged and distressed look. But there are so many different applications of this. Once the textures are in there, as the game progresses, let's say you play the game for 10 hours and you go back and revisit somewhere, you'll find that it's changed. It has a completely different look. It looks much more degraded and old than it was when you visited it 10 days ago. 10 hours ago. So this is very exciting. As I say, Logarithmic are working on this. You can see it there taking effect on the metal plate and making that more and more worn. And they're now developing their runtime solution for this. So what are the limiting factors at the moment? What's stopping more of this happening? Well, art is becoming far more technical. There's a certain new role that's clearly developed over the last year, the last 18 months in games development, called the technical artist. The technical artist, yes, it's somebody who understands shader programming, but it's somebody who also is starting to understand some of these techniques which rely on programming as well as art to really get the best out of them. Artists are becoming much more like directors, almost like mini directors of a particular area as you get in the film industry. But in order for them to really get the most out of what these procedural technologies deliver to games, the tools are going to be the key thing. It's going to be very important to have tools, almost like, if you remember the spore creature creation set we saw there, you can change things and tweak things very easily. That's what we want for all of these tools, for plants, for textures. There need to be tools around them that allow the artists to rapidly iterate, rapidly create more content, but then change it very quickly. They don't quite like how that looks, so they're going to change it again very quickly. So the tool framework is the key, and there must be a really streamlined pipeline to allow the artists to take control of that. But the new race of next generation content is going to be creating content by processes, by code, rather than by hand. So artists are going to become these manipulators of content. The artistic challenge is always to keep control of the content and make it look realistic or natural or fit with the style of the game that you've got. So you're always going to need the artists. It's not going to be suddenly that artists overnight will disappear because everything can now be created by code. That's not the case. Somebody still needs to maintain the artistic vision and use these tools. But new skills will be required. Artists, as I've said, will have to become directors. And the key areas you're going to see this developing in are cameras in games. Already there are people working on analyzing directors like Steven Spielberg and working out through a set of rules how he uses the camera, how he focuses at a certain moment, how he pans, how he pulls back, how he pulls the shot, analyzing that and translating it into a rule set. Textures we've looked at, animation, lighting, all of these are going to be things that need artistic input, but at the end of the day are going to also require a real understanding of programming, code, and procedural synthesis. So I hope you can see from the areas that we've covered here that actually programmer art really is the new call. Programmer art is the way forward. Generating art through code is going to be the way that a lot of games will cope with these rising hurdles where people say you need teams of 150. They're saying, well, we can't hire 150 skilled artists in Helsinki, in Finland. We can't do it. We can't find them. And the way of getting around this is using this type of approach. But what does this really mean for gaming then? How is this going to change the games that you're going to play on PlayStation 3 and the other consoles in the next few years, in the next 4 or 5 years? Well, some games will change and some games won't. There's going to be a huge spectrum of games, from the very procedural, so we've seen Spore, where everything is procedurally generated, right through to the scripted games like GTA. GTA has a very careful storyline. It has very careful setups. It has very detailed environments, very specific things that are completely unique and individual. And probably that will still continue to be the case, and a game like GTA will still use a very scripted approach. But there'll also be titles like Just Cause, which have quite a lot of procedural content and some scripted content as well. And maybe that will move more towards the procedural side as time goes on. More and more elements will be added to make that more and more procedural. But what it does mean is that games are no longer static. It means that effectively games can change and evolve very quickly. They can change whilst you're playing them. They can change immediately, as you're going through each of the levels according to how you're playing it. There will also be consumer-specific changes. So the way you're playing a game and the way the game looks to you is going to be different to the way your friend is playing the game sitting next to you, because he's done different things. He's affected the world in a different way. And all the content in there can be generated and destroyed and changed as you play the game, without needing to download a patch, or without needing to get new content, or without needing to do something else to the game, or enter a new level. All the user responses and actions that they create as they jump from a platform to platform, as they kill a particular creature, they can all be incorporated back into the gameplay. So if someone's playing a game and they're going through it and they're just killing everybody in sight, the game will become very dark, the textures will become very distressed, the animation of the characters will become slumped and depressed. Everything will make you feel as though it's kind of quite a heavy atmosphere. On the other hand, if somebody's going through and playing it and they're healing everybody, let's say, then everything's quite light, everything's airy, the lighting reflects it, the whole mood reflects it. It also means that games are going to become much more platform independent. Things can be ported across to other platforms and moved across to other devices much more easily. And the experience is going to become more scalable. So just to conclude then, what can we say? Well, tool providers are really going to become the key pillars of next generation in these respects. And to a degree, you can imagine that the companies who control these tools, who develop the genetic blueprints for a wood texture or for the biometric skeleton of a human, these genetic thumbprints for those individual things are going to become very, very sought after commodities. Nobody's going to need to create the wood texture definition again, because once it's defined, it's defined. You can change it procedurally many, many times to create the variant you want. The important part of the work is to describe it in the first place. So those initial genetic thumbprints of those materials or whatever are going to become very, very important. Developers will become directors rather than creators. The way of creating all this content will become easier. It will become more rapid, and it will become easier to change it. So developers won't spend all their time just getting all the stuff in a game together. They'll put all the stuff in the game together much more quickly, and then they'll direct it, and they'll manipulate it, and they'll craft it, which is, I think, something that developers have been aiming towards and hoping for a long time. And the games themselves, as we said, the minute they hit the shelves, the minute they go on sale, is the minute that the game starts changing and being customized and personalized to the individual players. If they're online, the games can also be shaped by the community. So if it's a massively multiplayer game, the players can shape a particular area of the world exactly how they want it and change the content without the need to wait for Blizzard or whoever to release the next pack or the next patch. And the game experiences themselves will become far more portable, as we've said, multiple devices there. So that's the end of my talk. I hope that's kind of given you an insight into where I believe some of the more exciting aspects of next generation are heading. This is one aspect of next generation. This isn't everything that next generation is going to deliver. We haven't even touched on the high fidelity visuals or audio or anything like that. The application of network, how that's going to work. But this is hopefully a little bit of an insight into where I see the future going in the next 3 or 4 years. And obviously, I'd like to thank as well Natural Motion and Logarithmic, who contributed some of the footage you've seen today. So that's it from me. If you, I think we've got some time for questions now. Got about 10 minutes. So if anybody has any questions now, please go ahead. If not, I'm going to be here afterwards as well, so you can come up. If anyone is interested in PlayStation platforms and developing games for PlayStation platforms, I have some brochures here you can take away that tell you a little bit about PSP, PS2, PS3, maybe how you can begin thinking about that. But feel free to come up and see me afterwards if you want to get one of those. Otherwise, thank you very much.